Hello everyone, welcome back to the class Real-Time Systems. Previous class we have discussed about the supervisory control and also the loop controlling. It's also called as the DTC control. See in this video, this video we are going to talk about the centralized computer control. In 1960s, the computer control implies the use of one central computer for the control of the whole plant, mostly due to the financial reasons. Okay, although the general purpose computers can be programmed to perform all of the required tasks, the different time scales and also the security requirements for the various categories of the task makes the programming job difficult, particularly with regards to the testing of a software. See, in 1960s, the computers were not very reliable. So the mean time failure of the computers were the order of the few hours, and to achieve the mean time to failure of 3 to 6 months for the whole system, which is required defensive programming to ensure the system that could continue running in the safe condition while the computer was repaired. Okay, so in the mid of 1960s, the traditional process instrument company which begins to produce the digital controller with the analog backup. Okay, after that, in 1970s, the cost of the computer hardware was being reduced to some extent. Uh, so, um, so the computers are become very feasible to consider the use of dual computer system as shown in the figure. So where it is, as it like this, the dual computer can be used because in 1970s the cost of the computers are reduced, so we can go with the two computers parallelly. Okay, for the controlling application, for the controlling reasons. So here we can change it's an automatic or manual changeover. It is possible here. So we can change it to the automatic, or also we can change it to the manual operation. So the weakness is nothing but the cabling and also a interfacing equipment software which is not duplicated. The question over the reliability of the changeover equipments. Okay, so this is the weakness of the particular system. Okay, so here when we are using the dual computer which is connected in this particular thing, hence in the event of the failure of one computer, the other will take over the task. In some schemes, the changeover is done manual, and in the other by the automatic manner. Okay, so if there is failure, if there is failures are occur. Okay, so the continuous reductions of the cost of the hardware made the development of microprocessor for the multi-computer systems. So they will be fall into the two categories. So the continuous reductions in the hardware that will be fall into the two categories. One is the hierarchical system and also the distributed system. So what is a hierarchical system? Hierarchical is nothing but the task which will be divided according to the function. And the distributed system is nothing but the mini computer which performs essentially similar task in parallel. Okay, so this is nothing but hierarchical and digital systems. Okay, so the next one what we are going to talk is the hierarchical system. So in this, I have told you that the hierarchical system, it is nothing but the tasks are divided according to the function. For example, with one computer which is performing the DDC calculation and other being the supervision to another, to another which performs the supervisory control. Okay, so it will be divided according to the functionality, one which performs the DDC operations and another one which performs the supervisory control operations. See, if you can see here in this diagram, there is a decision making here. So the inputs are here, the constraints and also here the information constraints, which is the input. So the inputs are constraints here and also the commands which come here. Okay, and if you can see here, the output is nothing but an information. Same way here the constraints are comes here, the information is nothing but your output, and the informations are the outputs here, and here the input is nothing but the information. Okay, so here So if you can see here the hierarchy which is divided here, so one single system, and in down if you can see here there are three systems are there, and under the bottom level there are two systems are there. So depending on the operations it will be divided. It is on long one and decision time scale, and it is nothing but on the short one. So the top level it is nothing but single decision center, and these are the intermediate center, and this is nothing but on the bottom level. So the many of the decision centers are there here. Okay, so this is about the hierarchy. Okay, a typical company decision which making the structure which is shown in this figure. Okay, so the each decision elements which receives a command from the level above and send the information back to that particular level. So in previously we have seen the diagram which is in the triangle. Inside the triangle there is a one the top level and the intermediate level and bottom level, right? So the top level is nothing but on the manager level, and middle level it is nothing but the supervisor level, and bottom levels and all it is on the working, I mean the units. Okay, so like this goes. So the one system which gets the informations and send the informations to the higher authority. So based on that the decision will be taken. Okay, so the each decision element receives the commands from the level above and send the information back to that particular level. Okay, based on the information received from the element or the elements below and the constraints imposed by the elements at the same level, and send the commands to the elements below and the informations to the elements at the same level. So the faster response as you go down the particular pyramid. Okay, so the typical examples of the hierarchical system, which is the batch control using the hierarchical systems. So there are three levels. One is the manager level and supervisory level, and also a unit control level. So this is all about here the hierarchical systems. And the next is the distributed system. So in this distributed, the underlying assumptions of the distributed approaches are that each unit is carrying out essentially the similar task to all the other units. Okay, so in the event failure or overloading of the particular unit, all or the sum of the works can be transferred to the other unit. So the distributed is nothing but the work will be distributed among all the systems which performs the operation. So each and everything which performs a similar task only. If there is any failures are occur that, or if there is any overloadings are there, that particular task can be transferred to the neighboring systems. So that is the main assumptions of this distributed approach. So if you can see here, these are the one of the examples of this distributed approach. Okay, so before going to see this diagram, actually the concept which is behind in this distributed system is that the many hands which makes the light work. Similarly, the total work is divided up and spread across the several computers. Okay, in order to gain the advantages of these approaches, the allocations of the task between the computer has to be dynamic. Okay, in modern scheme, a mixtures of the distributed and also the hierarchical approaches are used. Okay, now see in this diagram you can see this hierarchical and also a distributed which is combined here. Okay, now in this diagram the functions are divided. The functions are divided into the 5 broads. Okay, so the level 1. So in that level 1 you can see here the measurement and actuators. So all the computers and plants interfacing associated with the measurement and also activations. Okay, so the level 2 all the DTC calculations are done here. And in this level 3 sequence control. Okay, so the level 3 is nothing but all the sequential calculations are done here. And the level 4 the operator communication. So operator whatever the communications which is there that will be performed in this particular level. And this level 5 the supervisory control. So supervisory control systems are performed here. And level 6 is nothing but the communications with the other computer systems. The next last one, the communications with the other computer system. So it is not necessary to preserve the rigid boundaries. Okay, it may be and beyond this also. Okay, so what are the major advantages of this hierarchical systems? This particular system. So the system's capabilities are greatly enhanced by the sharing of the task between the process. So the system is much more flexible than the use of the single processor. Okay, if there is any failures are occur or if there is any disturbance or the overloadings are occur, only the small portions of the overall system will not be working. Okay, remaining all those things are working properly, right? So this is all about your hierarchical system. So the next is human-computer interface. The key to the successful adoptions of the computer control scheme is often the facilities which is provided for the plant operator for use of the systems. Okay, so the simple and clear system for the day-to-day operations of the plant that must be provided here. All the information which is relevant to the current state of its operation that should be readily available, and also the facilities to enable the interactions within the plant. And when we come to this benefits of the computer control systems, what are the benefits? So far we have discussed about the computer controlling systems. So what are the benefits of this computer controlling? So before the widespread availability of the microprocessor and then computer control was expensive, and a very strong case was needed to justify the use of computer control rather than conventional instrumentations. Okay, in many applications the flexibility is very much important. It is difficult with the conventional system to modify the sequence procedure to provide for the manufacturer of a different product. Okay, so these are the benefits of computer controlling systems. Okay, so these are the references. I hope this video is very helpful for you. We'll meet you in the next video. Thank you all.